Fire Rescue, and I think I'm the oldest guy here in the room. With me today, coming from Station 2, Fire Station 2 in the Miami area, is Captain Ricky Stevens, who is riding the engine so that I can participate in this hangout. And not only is he a stellar guy, but he's quite an athlete. In 2012, Ricky finished first in the over 40 category of the Firefighter Combat Challenge in Myrtle Beach. And in 2014, he finished third in the Combat Challenge in Dubai. So kudos and thank you very much, sir, for being here.
Sir, for having me.
And the other fellow I want to introduce is Captain Mike Posner, who is here on a very serious mission. He is going to relate a very close call that our department experienced with an elevator. So before I make some introductions, I want to give a shout out to our sponsor, Key Hose. That would be Key Hose or keyfire.com. Hopefully you'll be fortunate enough to make it to FDIC, and they will be in booth 2337 at FDIC in Indianapolis this next month. As I say every month, it's a hearty, easy endorsement for me because I really don't think you're going to find a hose that has a better balance of durability, abrasion, heat resistance. It's very difficult to intentionally kink this hose. It just has outstanding resistance. We'll talk a little about a hose for standpipe ops today. And when we do, the friction loss of hose is a very important factor to consider. Certainly we want to be looking at hose that has the least amount of friction loss possible. So having said that, thank you so much, Key Hose, for having us on for another month. Nick Martin, sir, if you could, give us a brief introduction. Tell us a little bit about yourself.
Hey guys, Bill, thanks again for inviting me back here. I'm excited to hear what this panel has to say. My name is Nick Martin. I'm presently the training chief for the City of Columbia in South Carolina, the capital city here of the Palmetto State. Prior to my second career here, I was a lieutenant in the District of Columbia Fire Department, and I'm eager to talk about some of the topics we're going to have here today.
Oh, thanks, Nick. Thanks for participating. And Mike Dugan, sir?
Good afternoon, brothers and sisters. My name is Mike Dugan from the beautiful sunny East Coast. It's about 75 degrees here today. It's gorgeous. And I'm sitting in my basement for fire engineering. It's a great day. And we are here today to talk about high-rise operations, again, something that the City of New York has great experience with. And I would also like to ask each and every one of you to keep in your thoughts and prayers the members of Seattle. Our good friend Mike Galliano's company, Ladder 5, was involved in that gas explosion last night. And I know some of the members were injured. I don't know anything else as of yet. But please keep them in your thoughts and prayers. Thank you.
All right, Daryl Liggins from the West Coast, Oakland, California.
Good morning. Daryl Liggins. I'm with Oakland, California. I'm a captain here. This is my 23rd year in the fire service. I happen to be sitting at not my normal firehouse, but Station 7, which is in the hills bordering Berkeley. And it's unique because it's built because it's sitting in the middle of the scarred area from the Oakland Hills fire, where we lost 3,500 homes, including the property that we're on. Most of the houses up in these hills are built on hillsides where we enter the top of the house and would have to go down. So it could be a very dangerous area. But also in this district, we have the largest wood frame building on the West Coast, the Claremont Hotel. So although it's a single-family district, we have a unique high-rise problem here that it's an entirely wood frame high-rise building. So anyway, glad to join you guys here today.
Clark Lamping, sir.
Good morning, everybody from Las Vegas. My name is Clark Lamping. I'm currently the training captain of the Clark County Fire Department. I've been on the job for 18 years, and Again, as always, happy to be here with all the brothers and sisters out there on Fire Engineering's Google Hangout.
Real good. Bobby, any words?
Hi, I'm Bobby Halton. I'm with Fire Engineering and FDIC, and just wanted to remind everybody that we're about 30-something days away from FDIC, so things are really filling up fast. A lot of sold-out classes in the hands-on. Workshops are filling up quickly, so please register today and get the classes that you want, and get connected the way you want to be connected at FDIC. So there's still time to sign up for a lot of workshops, including Bill Guston and Mike Dugan. So be sure to take advantage of that. And we did the walkthrough yesterday. Everything looks great. I've got a few emails I've got to handle here, so I'll be in and out of this conversation. I'll be listening, but I'll be up and down from my seat. So I apologize for that distraction, but I need to keep moving stuff forward. Also, remember, if you want to talk to Bill or send in a question to Bill or Mike, if you put hashtag FETalk, you can send in your question for this discussion, and I'm looking forward to the discussion today, Billy.
Very good, very good. I'm going to turn the program over to Captain Posner here for just a minute. Captain Posner, Mike Posner, is on the investigation team of a very close call that we had. It had to do with an elevator. He's going to explain it. Now, he was not there, and he cannot speak for the people that were there, so we aren't going to really extend the hangout to include many questions. He's basically here to tell you what happened, because it could happen to any fire department that has a traction elevator. That means one that uses cable. It could happen to anybody, and it's just was a matter of luck it hadn't happened to us in the past. I also want to call out two individuals, Chief Leo Durkin from Clark County Fire Department, and my good friend Richie Avalone, who was a training officer for Pompano Beach Fire Department and worked in Midtown Manhattan in the elevator industry for many years before he came on the fire department. So I'm going to turn the program over to Mike. This is some serious business, and thanks so much for participating.
Not a problem. Good afternoon, brothers and sisters. The incident I'm going to talk to you guys today about occurred in a 12-story high-rise. They got a call for an alarm ringing. Companies arrived. The first arriving engine company arrived. They were met by a building manager that came out and told them the smoke detector went off in the elevator machine room on the panel. He went upstairs. He's already checked out the machine room. There was no smoke. There was no fire. The elevator was clean. The room was clean, but that he could smell maybe something had burnt. Engine 21 went and confirmed that with the alarm panel. It showed smoke detector in the machine room on the elevator. The engine company was crewed up with the aerial, and the aerial officer was going to go ahead and be the elevator operator. The elevators, when they got there, were already in phase one. Obviously, we've had the automatic activation of the phase one. The officer got the key out, took the elevator, put it in phase two. As they were making entry into the elevator, they looked into the shaft. Shaft was clear, no smoke, no fire. When they put it in phase two, they had a steady fire helmet. One of the issues that they had was it was a Region 7 key for the elevator. So when it was two elevators, but only one key. When they put the elevator in phase two, obviously you now can't take this key out of the elevator. So they only had the one elevator that they were able to use in fire service. They took the engine company crew to the 12th floor. The engine company got out and then made their way up to the machine room. And the officer in the elevator stepped out of the elevator for a minute. They exchanged some dialogue with the guys upstairs. They confirmed that there was no smoke, no fire in the machine room, but there was a light smell of something that had been burning. The officer got back in the elevator. He was going to go back down to the first floor, and he realized that there was no power to the elevator. The elevator was dead at this time, so he radioed up to the guys in the machine room and asked them, did you guys kill the power? Apparently, right before the guys had walked in, the building maintenance guys had come in and killed the three-phase power to both of the elevators. At the same time, there was a firefighter in the elevator on the first floor who had got into the elevator to see if he could find a key somewhere in the elevator, if it was misplaced. When he got in the elevator that he got in on the first floor started to go up. He didn't realize it, and somebody yelled to him to get off of the elevator. He jumped off of the elevator, and then the elevator took off uncontrolled to the 12th floor, and it smashed into the roof. The captain that was upstairs on the 12th floor reported an immediate rush of air, and then the guys said they heard some sort of an explosion, and debris blew out through the hoistway doors of the closed elevator as it made its connection with the roof. At the time the guys came back, the cables had some sort of an explosion, and they were free spooling, and that the counterweight dropped all the way to the bottom floor. So at that point, an urgent was sent out. The chief picked up on it immediately, did a PAR, made sure all crew were accounted for. Everybody was accounted for. Nobody was injured. After we got there and we did a little bit of a research on it, and we met with the elevator company, we found out that the issue was that the relay switch on the brakes had failed. And when relay switches on a cabled elevator fail, the natural position for the brakes to go into is to go ahead and actuate. And now the brakes are on the drum inside the machine. And the elevator kept working normally, and up and down, and eventually the brake inside the drum started smoking, which then caused the smoke detector to go off in the machine room. When the elevator power was killed, this was actually where the issue came from. Once the relay switch goes bad and the brakes are actuated, the elevator is still held safely by the torque of the motor as long as there's power in the elevator. As soon as the power was killed, it lost torque. And it was similar to having a golf ball at the top of a hill. Gravity was going to work against it. All it needed was just a little bit of a push, and the firefighter that got into the elevator on the first floor moved the elevator enough to get the counterweight to start moving down. That's when he jumped out, and the elevator went straight up to the top. This was an older elevator. It was built, the building was from 1994. So it did not have an ascending governor in case of an emergency for an elevator that goes up, only for one that crashes down. Some of the big lessons that we've learned, one of the biggest one is elevator emergencies can never, ever be taken lightly or considered a routine emergency. We've always taught our guys that when you have an elevator emergency, one of the first things that you do is you go in and you kill the power. Killing the power on this elevator incident actually caused the problem. It is absolutely imperative that if you have an elevator incident, you have got to get to the machine room, and you have got to check the brakes, and you have got to make touches. If it's hot to the touch, be very careful. You don't want to, if you turn the power off, you're going to go ahead, and that could be the only thing that's holding that elevator in place. Super important also, have forcible exit tools with you. Had a firefighter been in that elevator when it went up. They had trouble getting the doors open from the hoistway on the floor. So it's critical to have your radio with you, all your gear, and your forcible exit tools with you at all times. Very, very important. Also, the importance of lobby control. We talk a lot about lobby control. Lobby control entails a lot of different aspects, and one of them is the elevator car operator, which is absolutely imperative to have in there as well. We were fortunate and blessed enough to have the elevator company assist us in the investigation, and it's an important message that we have to get out to everybody, how dangerous an elevator incident can be. And sometimes the things that we've learned in the past, we have to learn lessons from things that are happening now. This anomaly that happened to this elevator is a 1 in 12 million case of happening. Elevators just don't fall up with all the safety features they have in them. But thank God all of the brothers and sisters on this call were safe, nobody was injured, and it's an absolutely critical lesson to learn. Once we get it all finalized, we'll have it in writing, and there'll be a little bit more details. But please pass the message on these cabled elevator incidents. We're blessed and very lucky that nobody was injured or killed on this call.
Thank you very much, Mike. Thanks very much. Did we make some mistakes? I'm sure we did. But this is too important to sweep under the rug. Like I say, this is just the preliminary information. Again, thanks to Chief Durkin and my friend Richard Avalone and the elevator company, which would rather not have us mention specifically who it is. Okay, now we're going to get into our continued. Yes,
So
sir.
just one thing. One of the things New York City does is they have at every fire command post, the building has to have 6 elevator keys available. Might be something you want to look at in your fire safety planning for these buildings. We require them to have 6 elevator keys available for us.
Mike, that is getting to be a problem here. Captain Poser mentioned a Region 7 key. That's a statewide system. You know it in the old days, because I know you were around in the old days, you and I, that you could take a key, the same key that you put the elevator in phase 1 and recall the elevator. You could take that key, put it into phase 2 in the elevator car, turn it to the on position and take it out, and then go to the next car and do the same and the same and the same. You can't do that anymore. This new installation captures that key with the intent that you're going to have a designated elevator operator, which is a good idea. It's a good idea. So yeah, it is something that we are working on. This has been discussed several times. I want to talk a little bit about hose line selection for standpipe operations. If you want to get people hot under the collar and get some passionate discussion going, just talk about the subject of using hose smaller than 2.5 inches in a standpipe operation. That tends to get people riled up. It's like the 300 or 400 pound gorilla in the room. Everybody knows it's there, but we're not talking about it. The fact of the matter is there's fire departments every day in this country successfully extinguishing fires with hose smaller than 2.5, primarily 1 3/4 hose. So let's make some qualifications. Can I say this, please? The size of the fire dictates the size of the hose, which would indicate the amount of people and where they need to be placed on that hose line. The size of the crew does not indicate the size of the hose. In other words, don't tell the fire, hey, we don't have enough personnel to use 2.5-inch hose, so we can only use 1 3/4. The fire doesn't care about that. It is an unsympathetic chemical reaction. Can 1 3/4 hose be used safely and effectively in a standpipe operation? I say yes, but under certain conditions. Compartmented residential structures that are sprinklered, and not only sprinklered, but you have to know that the sprinklers are taking effect. Not just if it's sprinklered, you have to be able to open up that stairwell door and get hit with a cloud of misty white smoke. Perhaps after the main body of fire is knocked down, we'll spin off the tip of an 1 1/8 or 1 1/4 nozzle and add some 1 3/4 for maneuverability during overhaul. How about exposure protection, where you have an office floor that is so big and is generating so much heat, there's no way you can put it out by manual means or portable master streams. It may require multiple small diameter lines to protect that gap between the curtain wall and the spandrel beam in several areas. So we break down some of our larger size hose lines for smaller hose, the 1 3/4. You have to have good 1 3/4 hose. And here, another plug for key. 25-pound friction loss at 185 gallons a minute. So if we're bringing up 200 feet and we connect on the floor below, with the nozzle open, reading our inline gauge and giving us an ability to judge the quality of the stream, we're looking at 105 psi on our inline gauge while we're flowing. and that's at 185 gallons a minute. Now, having said that, every fire department that has the intention of using anything smaller than 2.5-inch hose must be trained, must be equipped to use 2.5-inch hose when necessary, and most important, to recognize situations where using anything smaller than 1 3/4 hose is going to be ineffective and dangerous. Also consider this, in an urban setting, the first due company, if they are confident that they can use 1 3/4 in a compartmented sprinklered high-rise, residential high-rise, fine. Take up the 1 3/4. Having said that, every other company that goes in that building, engine company I should say, should take 2.5-inch hose with them. Because that was the argument, not the argument, but the discussion and the assertion that Captain Mike Dugan had in one of our prior hangouts. What if you get up there and then you find out that the 1 3/4 is not going to be effective? Well, in this way, if you have other companies that are going to join you in short order, if, say, you had to stretch from a stairway that was not the closest, let's say you encountered a problem with a PRV, let's say that you had a building under construction that only had one functioning standpipe, any of those things that would indicate either a long stretch and or a low pressure situation or a volume of fire that you didn't anticipate, the 2.5-inch line will be there. So any thoughts on that, fellas? I know it's a controversial subject. Nick, I realize that your department is in the process of revising some of your SOPs, and if you want to go ahead and weigh in on that, please.
Yeah, absolutely. It's a very interesting time, I guess, for me because, as you mentioned, we're implementing a new high-rise operating guideline, really the first one that we've ever had here. And actually, the guys down at the academy right now are doing their multi-unit drill, which includes, a little presentation and some hose stuff with this. And we've been, as part of that, been building our new engine company complement. And to be honest with you, what you would find out there on the streets right now is kind of a hodgepodge. I mean, quite honestly, some companies have an 1 3/4 and some have 2.5, and they're pretty unreliable as to how exactly they're configured. But we've identified that as the problem, and we're moving forward with a solution. And we did some research and got some input from a lot of people and kind of came up with a concise list of what equipment we want an engine company to carry as far as the hose component and the accessories. And we have a demo version of it down there at the academy. And probably after this meeting, I'm going to head up to headquarters and try and work on submitting the purchase recommendations. And to make the long story short, eventually, what that'll end up putting on all the rigs is the 2.5-inch line with the smooth bore tips. And I think we're going with without looking at it, I think like an inch and an 1.125 kind of stacked thing on the tip of there. As I mentioned on the last show, kind of the interesting converse for me is that, the first 10 years of my career I spent in the Washington, D.C. Fire Department where we used exclusively 1.5-inch hose line on our standpipe packs. And to my knowledge, we still do. And, I'm not saying that as an endorsement or anything, but merely as a point of discussion that, it's in hindsight, I recognize a lot of the challenges that we did have and that we could have had with that configuration. But as I kind of mentioned before, due to some unique stuff in the nation's capital, there are some height restrictions on those buildings that other fire departments don't deal with. So that's kind of where we are and some of the things we've been looking at.
Mike, go ahead and weigh in on that, please. Mike Dugan.
Yes. Yeah, I understand. Again, it works a lot of times, and I have seen it work. I've also seen it fail. And unfortunately, in the New York City Fire Department, we buried some people because it failed. And I will say, your point about it's got to be a sprinkler building and the sprinklers have to be operational. The other thing I would add to that is that the standpipe for the sprinkler has to be fed so that we know that there's water in there and that it's doing its job. But, we can list firefighters who've died in the hallways. Lieutenant Cavalieri firefighters Bohan and Bop down in Vandalia Avenue in the original wind-driven fire. Someone across the hallway opened up the door, gave it a flow path to go, and that was it. They died in the hallway. They weren't even close to getting there, and they didn't even have a line yet. So again, you have to look at the building, size it up, kind of figure out know how big the apartments are, and know what your fuel potential is. And it's very, very difficult to sometimes figure that out. And again, it has worked. It has worked plenty of times. But I would hate for us to say that, well, you know, it worked for us the last 1,000 times we did it, and 1,000 the first time we buried a firefighter because of it. So we have to look at the water flow. We have to look at the volume. And the other thing that I will say very honestly is in today's fire environment, looking at what the science tells us about how quickly, I mean, fires aren't hotter. We know that. Fires reach the same temperature. But in today's fire environment, they just get much quicker. They reach that maximum temperature. And that is what we have to look at. How much water, how quickly can we get that water in place? And that's where the curve is. In a department without that many people, an inch and three quarter, we can get water on the fire a lot faster. But what is the detriment? And as you said, backing it up with the 2.5, that's fine. It depends on how many people you have and everything else. And all of these have to be taken into account.
Okay, Daryl, any thoughts, opinions?
Yeah, well, I certainly have a few thoughts, and one thing is that there's a lot of questions of when inch and three quarter is appropriate, and I never want to paint the picture that inch and three quarter doesn't work and 2.5 does work. Sometimes 2.5 may be defeated, and sometimes inch and three quarter is going to handily defeat the fire. I don't think we can really measure our line selection on the success or of the past, because sometimes success reinforces bad habits. I'm in a department that used red lines for a very long time for residential fires, and that's not the case anymore. We all know that's not appropriate, but we can't deny that they handled many structure fires around this country. A lot of times it is discussed about the size of the fire being the size of the line we're going to select. And I understand you said that, but in a lot of these buildings, we can't see what the size of the fire is. You can have absolutely nothing showing and then have a serious fire, or think you have a small fire, and by the time you get to it, a window fails, you have wind blowing in, and you have a totally different type of fire. So my question is, what is really to be gained by using a smaller hose line? I think it's overall just trying to make the job easier rather than working on our tips and techniques to make it easier for ourselves to use this more appropriate equipment, which I believe is 2.5 with a smooth bore nozzle. It's the way the system was designed and built to be used with. That can't be denied. If we're using something else, as John Norman said in his book here published by Fire Engineering, that we're using the system in a way it was not designed to be used. There was a blog talk recently done by Brian Brush here on fire engineering, and he is with a smaller department that uses some techniques on getting that line onto the ground, using the advantage of your body, and having even smaller crews be able to use the 2.5 successfully. And I would really encourage people to not just think a smaller line is going to be your answer to make your job easier, but working on your techniques. You know, listen to his class. He's phenomenal. He knows what he's talking about, and improves it on the fire ground with a lower staffed company than most of what our departments here represent today. I would also say that with residential structure fires, although they're compartmented, they can still get quite out of hand and have even a larger life safety issue if we don't get a handle on this. So I don't think, because of building is residential, that it's an excuse to use a smaller line. Standpipes, regardless if it's on a bridge, a pier, a wharf, or a high-rise building, they're still built under these same type of NFPA 14 standards.
You make an excellent point, and it's time for us to give another shout out to Key. It's like this is by design. If your department selects 2.5-inch hose for high-rise operations, do not go cheap. There are some manufacturers that will sell a hose, they call it high-rise hose. The only thing different with it is it's lighter to carry up the stairs. That's the only advantage to it. It has crappy friction loss and crappy kink resistance and horrible abrasion and heat resistance. So be very careful when you're buying hoses supposedly just for high-rise. Key Combat Ready 2.5 in terms of mobility, in terms of kink resistance, which is really, really important when you make that bend in a stairway. When you're coming from 1/2 landing to the floor landing is critical. And what's going to may make the difference between a successful operation with 2.5 and an unsuccessful operation is the quality of the hose in terms of its flexibility and its durability and its kink resistance. So you brought up some excellent points. Clark Lamping, sir, would you like to weigh in on this discussion?
Yes, sir. Thank you, Captain. We in Clark County use 2.5 in our high-rise packs smoothbore nozzles. One of our neighboring jurisdictions, they are still using 1 3/4 inch, and we cannot seem to convince them that that is not the right tool. I would encourage anyone who is using 1 3/4 inch in high-rise applications to hook up a couple flow meters on the line and make sure you are getting the gallonage you want to get, because just because your hose stream looks good does not mean that you're producing the adequate GPM you think you are. And I think you might be pretty shocked when you find out how much GPM you're actually putting out if you're using 1 3/4 inch in a standpipe situation. Now, in Clark County, Key Fire Hose was generous enough to lend us several hundred feet of their 2-inch hose, which I know this is a little bit off topic, but we are currently testing 2-inch hose for our high-rise hose packs, and I am getting great reviews from the men that are testing this 2-inch hose. So that's, again, another option. 2-inch hose flows 257 GPM you can get out of it, which is a good amount of water, especially in a high-rise situation. I would recommend maybe contacting Key Fire Hose and see if they could send you the information on it and possibly send you a couple sticks to try out.
Yeah, we've worked with it too, and we're getting flows of around 250 gallons a minute at 45 pounds nozzle pressure. That's on an 1 1/8 tip at friction loss of 25 psi per 100 feet. So it is a good mix between the 1 3/4 and the 2.5. Bobby, did you have any thoughts, or you're just sitting in and watching? You're just a spectator today.
No, I'm taking notes. There's several points. As the resident ombudsman, I think there are several great points made, and I think things to consider. First, on right and wrong, and never and always. Difficult terms, ones we should be careful about. But let's get to the heart of the matter. Heat release rates, as Michael talked about earlier, are up exponentially because of our polymer environments since the 1950s. What's interesting is we're talking about flow rates here, targeting 180 GPM, targeting 250 on our 1 1/8, which I think is good. But if we looked at them historically, those are the flow rates we were shooting for in the 1940s and the 1950s, 1960s, and obviously we know that the heat release rates, when we start talking about GPMs versus BTUs, that's the old thinking. Now it's the heat release rates and heat flux and things of that nature that we need to control. Michael brought up flow paths, which is a huge issue when we're talking about high-rise firefighting, controlling what we used to call before we decided to change the name, we used to call them cool air gravity currents, and then the high exhaust, heated exhaust gravity currents that are above us. Now we're calling them flow paths. Doesn't matter. But we reverse engineered a lot of our tools to meet our dilemmas. And one of the things that got reverse engineered, if you will, was the limited or reduced manpower. So we went to hose line that was lighter, obviously carrying less water because it could be deployed more quickly. Well, there's always two schools of thoughts: maneuverability, being able to hit faster and move. But when we're talking about a high rise, where your fuel loads we know are extremely high, and where your ability to reposition yourselves to areas of safe refuge can be restricted because of the way they're constructed, I think we need to focus more, as I think has been correctly said by everybody before me, on having adequate flows, or maximum flows, I think is a better word, maximum flows possible from our current technology. And I think that we restrict ourselves in our thinking because we're not looking at all the technology available. We're just looking at what we currently believe to be best case technology, like the inch and the eighth. Are there tips that will give us more than 257? Should we be looking at that? And I think again, we need to look at all our tools. I think that when we're talking about mounting attack against a well-seated fire in a high-rise residential, I think we should certainly be talking about bringing our maximum flow rates possible to the initial attack. Now, in mop-up stages and things of that nature, or when we're searching for hidden fire after the main body's been extinguished, is it okay to employ smaller lines at that point? I think that's an incident commander's decision, and one that should be weighed against the available knowledge of the current conditions of the fire. So that, again, careful about the always and never stuff. But great conversation. I think that there's a lot of study that still needs to be done. I think that the organizations that have responsibilities for residential high-rises need to take it very seriously and need to prepare to flow the maximum amount of water possible to mount that initial attack. Whatever configuration that takes within your organization, I would encourage you to be open-minded, because there are delivery systems that will well exceed the 257 gallons a minute at 45 psi on an inch and an eighth, which is a good flow. I'm not knocking it, but we can do better, and we should do better, and we should be prepared, and we should be educated, and we should be drilling constantly in as realistic a condition as we can get to be able to address these issues, because the public expects us to be able to, and more importantly, our own people need to be able to, and they need to be able to be so experienced and so well drilled that they can adapt and adjust and modify their tactics and techniques when needed to look for what are classically now termed as the unknown unknowns, which we're always up against. So those are just the thoughts I had. A few notes here. Great conversation and enjoying it.
I got another issue. When I was researching can everybody hear me okay? I was researching the SOP departments, high-rise out, and I noticed that in some cases, the department requires the first due engine company's crew, the entire crew, the engineer, to take and go inside the department. They basically start at it. Everybody goes in. Now, one of the justifications is a three-person engine company, because otherwise you have two people going into the building with investigation. Another justification would be that you're going to use your entire first arriving company as lobby control. In other words, your engineer would be going to the fire pump, the officer would be going to the fire command room, to the panels to check the alarm history, and be operating the PA system to direct residents and evacuees. and occupants, and that the firefighters would be gaining information from the occupants, from security, from building engineers, and be recalling the elevators, all of which would take more than just 2 or 3 people. So there are those departments that advocate that the entire company, be it 3 people on an engine, 4 or 5, that the entire company go into the building, into the lobby, and begin operations there. Now, whether they remain at lobby control or not, but I'd like you guys to, especially Nick, are you riding 4 on an apparatus?
On good days, sure.
Okay, what's your feelings on that? Because I can see a justification. I can see the point.
Yeah, I mean, you can make a valid case for both argument, and not to scapegoat it, but I mean, you can easily say it's going to depend largely on response times and staffing. Is a second due pulling up right behind the first due, or is there a time gap? What's that staffing level, et cetera. I mean, I think it kind of gets at the argument that when we were researching our high-rise stuff and talking to a lot of people, there seem to be 2 schools of thought, and to put it vaguely or broadly, one school of thought, it's go upstairs and begin solving the problem now and hope you don't need the rest, and the other school of thought is begin setting up the systems now and then go up and put the fire out. And I mean, you could argue both sides based on different circumstances. I mean, what we chose to go with is to basically send, a rapid attack force up there to try and put this thing out before we need the rest of the big systems. So basically most of our first alarm complement concentrates on going upstairs and putting fire out and doing searches and dealing with the people in the most threatened environment. That's kind of where we fell on it.
Yeah, and that there's 2 schools of thought on that, as you said. But let's make this clear that if you're on a department that requires that first arriving engine to go up into the building, make an ascent via the stairs or elevators, they still have certain things that they need to know before they leave that lobby. Absolutely, they have got to check the panel. They got to check the alarm history on that panel. They got to get an idea of occupancy floor plan, a little bit of information from security or the building engineer, information on the elevators, recall the elevators. Does the building have a smoke control system? Those types of things. You need to know that. You just can't blindly, literally or figuratively, head up the stairs.
Yeah.
Now, Mike, you're in a whole different situation there because of your resources. I can't imagine in the FDNY that they're going to that the whole engine company is going to be going into the building.
No. The first thing is the first engine chauffeur is going to automatically supply. If there's a sprinkler, we're going to supply the sprinkler. If there's a standpipe, we're going to supply the standpipe. If it's a combined system, we're going to supply both. The second thing that's unusual, I guess, in New York City is that any building that puts a fire alarm system in, we mandate that they have trained personnel that are trained by a school that's licensed by the FDNY to operate that system. They are the building's first line of defense. So we have a fire safety director or a deputy fire safety director. Then they are required in buildings to have a brigade, building employees who go to the floor below the fire, assist in the evacuation, and then, if possible, contain the fire. But they're in charge of the evacuation because sometimes these buildings, if we're going to the 60th floor of a building, by the time we get our people in there, get control of the elevators and everything else, we have a problem. We now ask these people to start doing the job. The fire safety director knows what's going on, and he is going to assist us, and he is going to be there. The chief's going to go right to him because this is his building. He knows everything about this building. He knows where the fire pump is located. Is it an automatic fire pump? Is it an electric fire pump? Is there a roof tank? Is that roof tank operational? Is every system operational? Where did the smoke detector go off? On what floor? What did your people see up there? Okay? So, again, it's just something we have the ability under the New York City Fire Code to make this mandated for buildings. If you put the alarm system in, you can't be like when the alarm goes off, the building engineer goes, "What's that noise?" It doesn't happen. You have to, once you put the system in, or if the building is required if by code to put it in, then it has to be put in, and you have to have people who know how to properly use it.
All right, Daryl.
I
Like to weigh in on that? You're riding 4 on an engine there, Daryl?
I am riding with 4, but at times we are riding with 3. The department allows that for a certain amount of hours at a time. But I worked in the suburbs before coming to Oakland, and we had 3 on a company. And I think the real important point there was for we had to have the engineer stay outside and connect to the building, because some of the even taller buildings are dry pipes. So the tallest building in the city of Oakland is a dry pipe. I know if you really know the building and you know it is supplied by a fire pump, the fire pump should be doing the work for you. And I think we can't treat a high-rise as a residential structure, and you know, be able to get a crew up in the building and start stretching the line. You're not going to get an argument from me. I really believe that the first company needs to get people to the fire floor with hose and start at least getting a line stretched. But with 3 on an engine, it is so important to marry another company together for that first line, especially if we're talking about long stretches or larger lines. We have to get 2 companies together as one. If the engineers are in the street doing getting water supply and plugging into the FTC, that leaves you 4 members total to get a line in place, and I think that's adequate to get that first line in place. I want to regress a little bit, since we were talking about the 2.5 versus 1 3/4, and with my time training, if anybody out there is going to start doing some drills with this, make sure you're pumping this line at lower pressures. Lower pressures, the better. If you are getting handily defeated by this line, most of the time it's being overpumped. Like Clark said, get a flow meter, flow it, and see what you're getting, but pump it at low pressures. And the other thing is, focus on the amount of work the water is actually doing for you. There's a lot of, it's easy to start thinking about how hard it is for us to do this work with our bodies, but the water's doing a lot of work for you. We can't treat the line like it's an 1 3/4 line, okay? More hit and move tactics, letting the water do some work for you. But I do think 4 people, each with 50-foot packs, will give you 200 feet of hose and enough people to get a line in place with 3 people on a company. But I'd like to definitely leave someone downstairs to start making those connections.
Clark.
Yes, Cap. Thank you. Clark County, we run 4 to an apparatus. First in company. They send 3 people up immediately. The 4th person, the engineer, he goes to the hookups and he makes the connections and establishes a water supply. The next 3 companies all go up together. So we send 4 companies directly to the fire floor. Directly to the fire floor. Our first rescue unit, and in Clark County our rescues and ambulance is 2 people. The first rescue unit will go to the fire control room and they will start gathering information like that. The 5th company on scene will establish lobby control. Now we're fortunate, again, we have 4 to a unit, and we have a lot of units right on our strip corridor, so we are not shy on personnel when it comes to high-rise firefighters. One thing that I would caution people at, if you do not have the proper staffing, high-rise firefighting is just as dangerous as hazmat incidents, as technical rescue incidents. You need to cross your T's, you need to dot your I's. Make sure all of your information is there as much as you can gather. For example, does your hazmat team in your jurisdiction, do they immediately pull up to a call, pull the e-brake, and jump into the green cloud and start making their assessment there? Or do they stay back, use binoculars, gather information, read placards, and try to gather as much information as they can before they put themselves into the hazardous material. Same thing with your technical rescue team. Does your technical rescue team immediately pull up, pull the emergency brake, and then jump into the trench with shovels and start shoveling? Or do they stand back, they make an assessment, they start to provide for the safety of their own companies before they enter the hazardous situation? It's the same thing with high-rise firefighting. These fires are not going to go out in 5 minutes, 10 minutes, 15 minutes, sometimes even 20 or 30 minutes until we can get water on this fire. So it's not the same as pulling up to a single-family dwelling, taking an 1 3/4 cross lay, forcing the front door, turning right, going down the hall, and putting 150 gallons in a room and contents fire, and we're done. We're high-fiving in the front yard 4 minutes later. It's not that. Please make sure you take your time. Make sure all your safety is in place, and don't expect this fire to go out quickly. Take your time. Take your time.
Clark, I couldn't agree more. I've been networking with a retired chief has more experience in high-rise firefighting and fire protection than I would ever hope to have. And that is the analogy that he uses. It's similar to a hazmat incident. There are certain things, certain amount of information that you have to have before you can take any action. The other analogy I'd like to use is a Class B fire where you're going to fight fire with foam. In other words, you have to be able to completely finish the job before you start, which means that if you're going to have to operate 1 or 2 2.5-inch lines under very punishing conditions, you're going to have a backup to a backup team. If you've got 6 people on that 2.5-inch line, you're going to have 12 people waiting in the wings, ready to go, because your first crew is going to be tired before they even begin. And under those punishing conditions, people are going to be tired out and out of air before you know it. And getting yourself in there with not enough people, you're going to run out of air and get yourself in trouble. You know that there was a fire in an office building in the southeast United States 2-3 years ago where, and this is just me, I think one of the factors is that they were struggling with a 2.5-inch line and perhaps didn't have enough people. And again, not to find fault, but are you prepared to do battle? And if you're not, then you're going to have to make preparations to do battle, get your hose lines laid, and marshal your equipment, your people, and your air bottles before you. The critical point is when you open the stairwell door, because that's letting the tiger out of the cage. And again, my friend that I'd like to think that he's my friend. He may not be after this webcast, but how critical it is to do not open the stairwell door to a smoky fire floor until you are absolutely certain that there are no occupants in that stairwell. And in a hot weather climate like Miami, that's not only above the fire, but that's all the way down below the fire as well.
The other thing I would like to say, Billy, is just, the New York City Fire Department, we joke that we are the Chinese Army because we just have so many people that we can bring to an alarm. And, average engine company is now, we call it 5-person staffing. It's an officer and 4 firefighters. And some of them have 6, an officer and 5 firefighters, 6-person staffing. But we go to a fire in a high-rise building, first and second engine company. Now, we're talking a lot of people. We're talking more people than some departments get on their initial alarm assignment are teamed up on that first hose line. There is, the first and second engine have the first hose line, the third and fourth engine have the second hose line. End of story. If you're the second new engine, you're backing up the first and you're relieving them as soon as they start to run low on air. They're out and you go in and finish up the job and everything else. But as we said, you have to have the people or know where the people are coming from. If not, this is the time that you think about other ways, alternative ways to get that water on that fire.
Such as portable master streams, exterior streams, flanking streams from another wing of the building.
Absolutely. Or if you don't have the people to I've heard it called the floor below nozzle that we use in the New York City Fire Department. I've heard it called the chicken stick, the cowards line, all that other stuff. One of the worst fires I was ever in my life. The way we put the fire out, the wind-driven fire. We moved down the hallway with 2.5-inch hose lines, and we got beaten off the floor. We got blown back. We ended up forcing an adjoining apartment and breaching a wall and getting water in there and letting the wind do the job. Put the fire out. As soon as we got 100 gallons of water in that apartment, the fire was out. But you have to look at other ways to do this, other ways depending on your manpower, your people, because listen, we're not in the business of burning firefighters as we march down that hallway. Our job is to put the fire out and keep our people safe.
Yeah, I couldn't agree more. We're going to be wrapping this up here real shortly. Again, I really want to thank Key, and it's so critically important, as I said before, that when you're selecting hose for high-rise operation, don't go cheap. The highest quality, the highest durability. Frankly, weight is secondary because that only applies when you're carrying it up the stairs. Be very careful about sacrificing durability in terms of heat and abrasion resistance strictly for the weight. Be very careful with that because my company has made that mistake in the past. You can't go wrong with the Key Combat Ready, regardless of the diameter of the hose. We can discuss diameter of the hose ad nauseum. The bottom line again is, because I'm hosting this, so I guess I get the bottom line, is that if you're using anything smaller than 2.5-inch hose, you better know your limitations. And you better plan for the day, God forbid, when that 1.5 inch, the power is going to his head. What did he go? The power is going to his head. I want to thank our participants today, especially if I can move in here. Ricky, for covering my spot. And how many patients did you kill while you were running my calls today? Not as many as I would have killed. Okay, all right, very good. And then those are all medical calls, though, not fires. And Mike Posner, thank you for that heads up. We'll get back with you. Any closing comments, Bobby?
Well, I just wanted to point out, and not to be braggadocious or anything, but Ricky, in 1995, the district chiefs competition for the Combat Challenge, I won. So while you were still at home with mom in nursery school or wherever you were in 1990, I'm just kidding. That's when it was old school. That's when you could still win with like 4 minutes. So,
yes,
or I think
not allowed, and you guys had to walk.
Yeah,
yes, absolutely.
I think I finished it in a day and a half, and then I was sick for 3 months. But no, I used to really enjoy the competition. Paul Davis does a great job, and thank you for what you're doing. Thank you for covering for Bill. Thank you, Key Hose. Thank you everybody for listening for us today. Again, this topic is so critical, and I have 2 quick points to make about it. Is that the tactics and that we're talking about, whether it's the nozzle, the below floor nozzle, or the dropping curtains to stop a wind-driven flame front, or the hose diameter, or the standpipe operations. One of the things to remember as the gentrification of our downtowns continues to evolve, and as we see more and more people moving into these residential, what we used to call taxpayer kind of situations, but now they're multi-floors. Some of them are now going up as high as 5 and 6 and 7 floors. Now they're low rises, but the tactics that we're talking about are going to be the same that we have to employ there. And I really have to tell you what Clark said. Man, I was jotting down notes and exclamation points. I mean, what a group of people. Everybody's input today was just amazing. I think this is a topic that we could have a discussion on for 5 or 6 or 7 hours and just be spellbound about the intricacy and the complexity of it. So I would really hearken everyone to not stop here, but to keep going forward with this topic. And as I was going through it, I was breaking it down. I think we could talk there could be a hangout bill on just, alternative tactics, whether it's curtains or nozzles or, even, dropping a Bresnan through the floor. I mean, there's all kinds of stuff we could talk about in terms of extinguishment. But thank you for having me. Absolutely, one of the highlights of my month every month is listening to this group. Always impressed by you folks, and Nick, was awesome to have you hanging out from your busy day. I know I'll see you all in about 30 days, and I love you, and we'll see you down the road.
I just have one more thing I would like to say. We have planned, and we're still on for April 13th is our next hangout. And all of our participants, we are going to tell you the classes we're looking forward to taking at FDIC. Not what we're teaching, but what we're looking forward to taking at FDIC and what we're looking forward to learning about at FDIC. And I think it'll be a great show, and I hope everybody can listen in to us the week before FDIC.
And really quickly, I will let you know that the FDIC Hot Committee is actively looking for proposals for FDIC Hot 2017 about high-rise tactics, alternatives, and issues. That's a hot class we're looking for. So if you're on this conversation or this topic intrigues you, or you're one of those people, Nick Martin, who could do something, now's the time to start putting your proposal together, Nick. Sorry. Bill, Bustin.
Hey, real quickly out there, you should see what we did in Las Vegas last week. If you go to Facebook, Clark County Firefighters on Facebook, we actually set a hotel room on fire on the 4th floor of a high-rise. We got some pretty impressive video on that. So, Chief Halton, if you're looking for someone to set some stuff on fire in Indianapolis in 2017, I'm your man.
So we off the air. I just need to interject.
Get it to me, but I'm not gonna. You had a high rise to light up there. Get it to me.
An FDIC road trip to Las Vegas.
No, I'm serious. For 2007, we're all about it. If you be all in, brother, be all in.
All right, my brothers, I got to go back and run door-to-door socialized medicine calls, unlike you other guys. So, because Ricky's got to go back to his regular job, and I got a lot of reports and other important things to do, and miles of smoky hallways to crawl down today. So the day is still young for me.
I'm looking at your group there of Bobby, Ricky, and Mike, and wondering if you guys were on Belle Biv DeVoe. Where's Johnny? Our audience might be too young to remember that. I would like people to think about what aggressive firefighting means. And being aggressive doesn't always mean being in the middle of the heat and the smoke and getting your butt waxed in there. It's being smart and aggressive. I think of something we would say at our class at FDIC about the Colin Powell doctrine. Read that if you're not familiar with it. But it's about using overwhelming force. We are firefighters, we're aggressive, and we have to be smart and aggressive. And big water, lots of people, and use overwhelming force. It's going to make a shorter campaign and have less casualties on both ends.
All right, my brothers. Goodbye. Stay safe. God bless you. Till next month.